So great, we know how to take a cross product, but why should we care? Are we just computing this because we love to compute things? Or is there some utility to the cross product? Well, as it turns out, the cross product does have many useful properties. Foremost among them is that the cross product of two vectors is orthogonal to both of those vectors. Let me illustrate with this example that we just did. So we took the cross product, we got 1, 10, 4. Okay. So U cross V is the vector 1, 10, and 4. Okay. Now let's see what happens when I take the dot product with U cross V and U, and with U cross V and V. Okay. So I'm going to take U cross V, and the vector I get from that, I'm going to take the dot product of that and vector U. So U cross V is 1, 10, and 4. U cross V. And then vector U is negative 4, 0, 1. So I'm just going to multiply corresponding components. So first component times first component, I get negative 4. Plus second component times second component, 10 times 0 is 0. Plus 4 times 1 is 4. Negative 4 plus 0 plus 4 is 0. And remember, when the dot product is 0, that's special. That means the two vectors are orthogonal. Geometrically, it means the two vectors will be perpendicular to each other. Okay? Let's do the same thing for vector V. So U cross V is still 1, 10, 4. And vector V is 2, negative 1, 2. If I take the dot product of these, I get 1 times 2 is 2, plus 10 times negative 1 is negative 10, plus 4 times 2 is 8. And 2 plus negative 10 plus 8, that's also 0. Which means U cross V is orthogonal to both vector U and vector V. Okay, let's see that in a picture. Let's see what that looks like. Okay, so here's our vector U, negative 4, 0, 1. Here's vector V in three-dimensional space. Okay, vector U cross V is this vector right here, and it's big enough that we can't quite see it all the way. There it is. That's vector U cross V. Notice that it is orthogonal to both vector U and V. It is perpendicular to both vectors U and V. This isn't just a property for this particular problem. It's not just a coincidence or a quirk. It's a general property of the cross product. Let U, not a definition, sorry, this is a theorem. Let U and V be three-dimensional vectors so that the cross product is defined, right? It only works in three-dimensional vector space. Then the cross product of U and V is orthogonal to both vector U and vector v. Okay, very useful property of the cross product, this orthogonality property.